Okay, so I wanted you guys to have this over the weekend in case some of you were studying for your test. So it says, Crew and Original were selling candy bars. Even though they are representing their rate of sales differently, their variables represent the same things. The X values represent hours, and the Y values represent the number of candy bars sold. Crew's proportional rate of selling is expressed by the equation Y equals 4X. Original's proportional rate of selling is expressed by the table. Then we see that here. So then it says, how many candy bars will the person with the faster rate sell after 10 hours of work? All right, so I'm gonna go ahead and graph it, what I know about Crew and Original, just so we can see that right away. So I'll start with Original since I have that table of values. So it says that he starts at 0, 0, and then he goes up to 1, 1, 2, 3, and then he goes up to 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the next one is 5, 15, so that's going to be off the graph. So this is Original's line. His line is going up pretty fast. Okay, so this is Original. So I'm going to label that. All right, so the next thing I need to do is Y equals 4X, which is Crew. So I know that Crew, Y equals 4X. So I know that his Y-intercept is going to be 0, 0, and then I'm going to go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4, and over 1. And I can see, I'll go ahead and use a different color. There is Crew's line. Okay, so I can see by drawing my graph who's going up at a faster rate. Okay, I can see that Crew is going at a faster rate. So when I'm answering my question here, Crew going faster because his unit rate is greater. Okay, now I need to figure out how much he will sell after 10 hours of work. So I'm actually going to go ahead and use my equation. Y equals 4X is the information I have about Crew. And I know that X, from the information here, X represents the hours. So that means X is equal to 10. So that means Y is equal to 4 times 10, and Y is equal to 40. So that means that Crew will sell 40 candy bars. Okay, how do I know that his rate is proportional? So there's a couple of things. One, it starts at 0, 0. 2, it forms a straight line and continues to grow at a constant rate. So what do I mean by that? Every 4 hours, every 1 hour, he sells 4 candy bars. That stays the same. It never changes. All right, so just to give you guys another example, I'll go ahead and do the self-check here. So in the self-check, I don't have the context, I just have the equation in the table. So it says, which data set will increase at a faster rate? So in order to compare them, I'm gonna do a quick table here. So I have X. Okay, so in the last one, I used the graph as a strategy, and you can always do that. Here, I'm gonna use a table as a strategy. So it's gonna be 0, 0. It's gonna be 1, 5, 2, 10, 3, 15, 4, 20. Okay, so which data set is increasing at a faster rate? This one is. Data set A. So what is the y value for the equation when x equals 6? So if my equation is y equals 5x, x equals 6, so that means it's y equals 5 times 6, y equals 30. Okay, what is the y value for data set B when x equals 12? So there's a couple of things that I could do here. So I could extend my table. So one thing I can do is I can see that if I want to just count up 11 and then 12, I can see that every time I grow 1, I'm going up 2.5. So I can add 2.5 each time and get 27.5 and 30. The other thing I could do would be to write my equation, y equals 2.5x, and then I could multiply times 12, which is essentially what I ended up doing here, and I get y equals 30. And how do I know it's proportional? Starts at 0, 0, forms a straight line, grows at a constant rate of 5/1. All right, so I hope that was helpful to you guys, and I'll see you on Monday.